Hello students, welcome back. Today we're going to talk about what is statistics. So the learning objectives are explain why knowledge of statistics is important, define statistics and provide an example of how statistics is applied, differentiate between descriptive and inferential statistics, classify variables as qualitative or quantitative, and discrete or continuous. And the fifth, distinguish between nominal, ordinal, interval, and ratio levels of measurement. And sixth, list the values associated with the practice of statistics. Okay, so the first big question on why we need to study statistics. Well, in general, data are collected everywhere and require statistical knowledge to make information useful. So you can imagine the state of data collection that we have in Indonesia and in the world in general is very different today than in the past decade or the past 2 decades. We have abundance of information at this moment. Data are being recorded everywhere, and given this insightful and rich data, how can we actually make information? And in particular, since we're in a business school, how can we take advantage of those data to make good and robust business decisions? Now, statistics is to make valid comparisons and to predict the outcome of decisions. Again, this is another feature of statistics that is very useful, is to help policymakers in general or business decision makers in general to make predictions and then to make decisions for these businesses or for their ventures. And it's very difficult to make decisions based on subjective judgments. Decision needs to be based on objective judgments, and in particular, it has to be based on data. So statistical knowledge is very useful for any career. If you're in business, if you're in engineering, if you're an architect, it's going to be useful if you understand statistics. That way you'll be making better decisions, and then you'll be making better business decisions. So what is statistics? Well, it's more than just presenting numerical facts, that's for sure. So statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in more effective decisions. Again, this is something that we need to underline, is in making more effective decisions. So if you want to make a robust decisions, or if you want to propose a policy to business decision makers, you need to make sure that your policy proposal or your business proposal is based on sound and robust data. So for example, the inflation rate for the calendar year was 0.7%. By applying statistics, we could compare this year's inflation rate to past observations of inflation. Or for example, if we're in the COVID-19 pandemic, we want to know what's the inflation rate during the pandemic. Is it higher, or we're actually facing negative inflation? Okay, that's another interesting facts that we can gain by doing some statistics. So the other thing is that we also want to know whether the trend of inflation is increasing in general and before the pandemic, and then whether the trend of inflation is actually decreasing during and after the pandemic. That's something that we need to know. Another facts on statistics that we probably want to discover is that is there a relationship between interest rates and government bonds. If you're interested in predicting the value of the government bonds given the current interest rates set by the central banks, then that's an analysis that you can go forward. Very interesting, and then this is why we study statistics. So basically there are two types of statistics. The first one is descriptive, and then the second one is inferential statistics. Now, descriptive statistics can be used to organize data into a meaningful form. Okay, we'll take a look on what a meaningful means. But basically, you can summarize data and provide information that is easy to understand. So you'll be facing business decision makers, executives. They have 5 minutes. You want to present them with facts and figures and tables that are intuitive so that they understand what business decisions that they need to make. If you present something that is overly complicated and then unintuitive, then it's going to be very difficult for your executives or your business decision makers to make any meaningful and effective decisions. So this is part of your job, not only to understand statistics in general, in theory, but also to present it in an intuitive manner. So in this course, you'll be learning how to organize, summarize, and present data in an informative way, in an intuitive way, so that it's going to be easy for people who read the information, to gather and to digest the information so that they can make that better decisions. So for example, there are 46,837 miles of interstate highway in the US, and then the US interstate system represents 1% of the nation's road, but carries more than 20% of the traffic. Texas has the most interstate highways, and Alaska doesn't have any. Well, this might seem a very trivial fact. This might seem like a fun fact to know. However, for a lot of decision makers, this is going to be very important in, for example, the development of interstate. This is going to be important in creating a policy to disentangle the traffic in this interstate. So might seem very simplistic, but this is actually a very handy statistics to carry. The second type of statistics is called the inferential statistics, and inferential statistics can be used to estimate properties of a population. Again, this is something about the population. Now, it really depends on the population itself. The population could be something that is quite small. For example, all the students in this statistics course. However, population can get quite large. For example, the population of households in Yogyakarta, or the population of households in Indonesia. It could be the population of teachers in Indonesia. It could be the population of small and micro firms in Indonesia. Very difficult to quantify. So what we're going to do is that for some of this population, where gathering their characteristics and their data is going to be quite difficult, then what we're going to do is that we're going to make decisions based on a limited set of data. So again, you have a sample that is relatively big, and then what you want to do is that you want to gather information, limited information, to make an inference about the population. So one thing that you will learn is that inferential statistics means that you're going to collect sample, and then based on that sample, you're going to understand or try to estimate or make some inference about the population. So inferential statistics is basically the methods used to estimate a property of a population on the basis of samples. So what is the property of a population? Well, one of the properties of a population is a population mean. Another property of a population is population variance. So that's something that we're going to estimate using samples. So this is just a quick example. In 2015, a sample of U.S. Internal Revenue Service tax preparation volunteers were tested with 3 standard tax returns. The sample indicated that tax returns were completed with a 49% accuracy rate. So there were errors about half of the returns. So what does that mean? Well, it could mean that there should be more training to these volunteers to further minimize the errors and addressing the tax returns by these individuals. Okay, again, I'm going to go back to discuss about population, and I'm going to go back to discuss sample, because these are 2 very important concepts in statistics. Actually, this is kind of like the central concepts on why we actually want to do statistics in the first place. So population is basically the entire set of individuals or objects of interest, or the measurements obtained from all individuals or objects of interest. Again, population could be something that we can readily observe, such as the number of students in a particular class, or for example, the number of houses in a particular complex, or the number of households in a particular complex. That's something that we can actually see, and that's something that we can actually gather data on. However, in many cases, it's quite difficult to get population data. Now, since it's quite difficult to get a population data, so what can we do? Well, as a statistician, what we can do is that we'll take a sample out of that population. So a sample is basically a portion or a part of the population of interest. It's a subset of the population. Okay, so in this particular case, in this particular example, you can see that the population is all the cars that is listed, for example, in a particular parking lot, and then the sample is just 6 randomly chosen sample or 6 randomly chosen cars from this population. So this is another term that I introduce you here, is that the sample must be randomly selected from the population. Say, for example, if you don't randomly select the sample, you could end up with all black cars, for example, or you could end up with all red cars. Well, if that's the case, then your sample doesn't really represent your population. Your population includes cars with different colors. They have green cars, and then yellow cars, blue cars, red cars, and then black cars. But since you're not choosing the sample in a random manner, then you could end up sample that is biased. In other words, it's not going to be representative of the population. Now, what happens if your statistics actually doesn't reflect your population? Well, the issue is that you're going to make not so good business decisions, and you're definitely not going to make effective decisions. So it's very, very important for you guys to make judgments or business decisions based on robust sample. Okay, now there are 2 types of variables. The first one is qualitative variable. So an object or individual is observed and recorded as a non-numeric characteristic or attribute. So for example, gender, province of birth, district of birth, the eye color, those are examples of qualitative variable. Now, we're also interested not only in qualitative variable, we're also interested in quantitative variable. So it's a variable that is reported numerically. For example, balance in your checking account, basically the amount of money that you have in your bank. The life of a car battery, if you can measure it, or if you can have a tool to actually measure the life of a battery. The number of people employed in the company, the salary of that employee, and then the wages of that employee, the profit of the company, the total cost of operation for the company, and so on and so forth. So this is quite simple, but in a lot of cases, students actually overlook a simple definition such as qualitative versus quantitative variable. And later on, where they get into an advanced stage of learning, they can't distinguish whether this is a qualitative variable or this is a quantitative variable. So here, you gotta kind of like start to build up this kind of like intuitive knowledge about what is a quantitative and what is a qualitative variable. And one way to do that is actually to provide examples for yourselves, whether it's a qualitative variable or this is a quantitative variable. So that's something that you need to work on. Now, so just going through the quantitative variable for a second. So quantitative variables can be discrete or they can be continuous. Now, discrete variables are typically the result of counting. Okay, so values have gaps between the values. For example, it's the number of children in the house. We have 1 child, 2 children, 3 children, 4 children. That's one example of a discrete quantitative variable. Another one is the number of bedrooms in a house, the number of students in a statistics course, and so on and so forth. So think about examples of discrete variables. Another quantitative variable is called the continuous variable. So this is basically the result of measuring something. So I've mentioned example of what's the wage of workers in your particular company, and what is the profit of a particular company in a given period. That's another example of continuous variable. Here is the duration of flights from Orlando to San Diego, for example, and students' grade point average or GPA. Okay, so again, just to summarize the types of variable, we have the qualitative variable, we have the quantitative variable. So the qualitative variable, examples of qualitative variable include brand of PC, marital status, hair color, and so on and so forth. And then the sample of quantitative variables include discrete variable and then continuous variable. So discrete is kind of like the children in the family, the number of TV sets owned or the number of cars owned. And continuous is the amount of income tax paid, the weight of the student, the yearly rainfall in Tampa, Florida, and so on and so forth. All right, so let's switch gear into the next subtopic, which is the levels of measurement. So again, we just discussed the types of variables, quantitative, qualitative, and then for quantitative, you have discrete, and then you have continuous variable. Again, these are something that has to be intuitive. Okay, so when you hear of a variable, you know that this is a qualitative variable or this is a quantitative variable. So that's must be something that is intuitive for you. So the next definition that needs to be something that is intuitive for you is going to be the level of measurement. So there are basically 4 levels of measurement. The first one is the nominal, the second one is the ordinal, interval, and ratio. Okay, so it's very important to understand, not only to memorize, but to actually understand the levels of measurement. Why? Because the levels of measurement is going to determine the type of statistical analysis that you can perform. Now, the issue is that, well, a lot of students, at least in my observations, they calculate mean for ordinal when that's not actually the appropriate statistics to estimate given the type of data. Now, this is something that you want to avoid. This is something that you want to, when you want to make a decision, you want to make sure that it's actually the right types of analysis. Okay, so nominal level of measurement, data are recorded at nominal level of measurement and is represented as labels or names. They have no order. They can only be classified and counted, such as, for example, the eye color, or for example, it's the brand of TV. Then that's an example of nominal level variable. Now, another example is identifying students as a football game by gender, classifying M&M candies by color. You have, blue, green, red, yellow, and so on and so forth. Now, after you have the nominal level, the next step is the ordinal level. So basically, the rankings are known, but then the magnitude of differences between groups are not known. So the data recorded at the ordinal level of measurement is based on a relative ranking or rating of items based on a defined attribute or qualitative variable. Now, variables based on this level of measurement are only ranked and counted. Okay. So, for example, it's the list of top 10 states for business climate. So, for example, you can have a state or a province with rating of 8 in terms of business climate, but then you have another state with a rating of 4. It doesn't mean that the province or the state with a rating of 8 is actually twice as better in terms of the business climate as those with a rating of 4. So the rating only puts you on whether you're better or you're worse than the other state or the other comparison, but it doesn't tell you by how much. So that's ordinal level of measurement. Okay. Another thing is student rating of a professor. So one professor obtain a rating of 10 and another professor obtain a rating of 5. It doesn't mean that the professor with the rating of 10 is actually twice as better as the professor with a rating of 5. They're just better, but not twice as better. So that's something that we need to understand when we're dealing with ordinal level of measurement. So we have the nominal, we have the ordinal. Now we're going to go through the third one, which is the interval level. So this data has all characteristics of ordinal level data. In addition, the differences between the values are actually meaningful. Okay. However, we must note that there is no natural 0 point. So for data recorded at the interval level of measurement, the interval or the distance between values is meaningful. Now, the interval level of measurement is based on a scale with a known unit of measurement. So the classic example of interval level is going to be temperature and dress sizes. Okay. Now, the last one is going to be the highest level of measurement, and this is referred to as the ratio level. So the data has all the characteristics of interval scale, and ratios between numbers are actually meaningful. And 0 point represents the absence of the characteristics. So data recorded at the ratio level measurement are based on a scale with a known unit of measurement and a meaningful interpretation of 0 on the scale. Wages, changes in stock prices, and height. Okay, these are examples of ratio level. Very meaningful, very straightforward, and there are a lot of examples of ratio level. Okay, just to wrap up on the discussion of levels of measurement. So there are 4, starting with the first one is the nominal, and then the ordinal, interval, and then ratio. So for the nominal, data can only be classified. However, on the ordinal, you can actually rank the data. Okay. For the interval, the meaningful there's a meaningful differences between the values, and then for a ratio, there is a meaningful 0 point, and then meaningful ratio between the values. So these are the level of measurements, and it's very, very important for you to be able to identify whether a variable is a particular type of level of has a particular level of measurement. Okay, so for example, if you hear income or if you hear business profits, then you know that it's going to be a ratio. Or for example, if you hear the car brand, for example, like Honda, Toyota, Mazda, and so on, you know that this is actually going to be a categorical variable or a nominal variable. So that's something that you need to know. Or for example, if you're looking through your Gojek and you're trying to get some food in your GoFood, and then the GoFood provides you with lists of restaurants or list of partners, and then one has a rating of 5 and the other one has a rating of 4.2, then this is an example of rating, and it's an example of ordinal variable. Okay, so just to get through the ethics and statistics. So practice statistics with integrity and honesty when collecting, organizing, summarizing, analyzing, and interpreting numerical information. So as a statistician or as an analyst in your office, you may find facts based on the data that you have. Now, it may be quite difficult to present these facts if these facts are actually not in line, or it's not actually aligned with the company's objectives or the company's goal. Now, you'll be very tempted to actually perhaps do some manipulation of the data or crunch the data in such a way to actually mask those imperfect statistics, if you will. But that's not the way that a statistician should act. You should report the data as is. You should report the data as you receive them, and then you also have to declare some of the procedures and processes that you take to actually get the final results. So replicability is actually very, very important in statistics, and this is something that is important for students to learn. So in this particular course, you'll be dealing with simple data, you'll be dealing with clean data, and this is where you're actually going to learn about reporting them in a truthful manner. So another point is that you have to maintain an independent and a principled point of view when analyzing and reporting findings and results. Okay, so reports that are based on data, you need to question, or you need to doubt reports that are not based on data that has a sample that is not representative of the population. Again, that's going to be quite a worry, because any statistics that you're going to generate is going to be a biased statistics, as this is not going to be representative of the population. And a biased statistics will lead you to a bias or ineffective decision. Another report that you want to question or you want to doubt is that one that does not include all relevant statistics and introduce bias in an attempt to mislead or to misrepresent the statistics that they generate. Top-level executives, top-level economists have done these mistakes in the past, and then this is something that we don't want to do. We always want to be transparent in the way that we present, or back to when you collect data, when you summarize, until you present the data, you have to be transparent, and then you have to be accountable. So your results could be replicated, and the replication will generate to the same result. That's the best thing that you want to achieve. But again, in practice in general, there are going to be issues, ethical issues. So you just have to be very mindful of these issues, and then keep your integrity and data analysis in general. This is the end of lecture 1, and thank you for your attention.